Welcome back. In this class we are going to discuss about the sheet resistant concept applied to inverters. Okay, just to recap, we know that in N transistor channel the sheet resistance value is 10 power 4 ohm per square, and for P transistor channel it is 2.5 into 10 to the power of 4 ohm per square. Okay, in which technology? 5 micrometer technology. Now I am going to use only this technology to discuss about the sheet resistance concept applied to inverters. Okay, for just recalling purpose, for 2 micrometer and R bit 1.2 micrometer, N is 2 into 10 to the power of 4 ohm per square, whereas P is absolutely 4.5 into 10 to the power of 4 ohm per square. Okay, now we will see how this concept is applied to inverters. How many types of inverters basically we are talking about from the starting of this course? Okay, NMOS and another one is CMOS. Now first of all, let us consider NMOS inverter. Let us assume that this is an NMOS inverter given in your examination point of view. Okay, let us consider it is VDD and VSS, and we know very well it is a depletion mode transistor, and the gate should be connected to source, and it is an enhancement mode transistor. Here you are having a V in and here you are having a V out. Now let's take the ratios length and width as 4:1, and for enhancement mode it is 1:1. Let us understood what is the question for you in your external point of view. They will ask the question, calculate on resistance between VDD to VSS for the NMOS inverter shown below. They are going to ask in this manner. First of all, you should find out the on resistance of depletion mode, and later you should find out the on resistance of enhancement mode, and after that you should club these two. That is an important task. Is it clear? Now we know very well how to find out the on resistance. From the last class we have seen sheet resistance concept applied to MOS transistor. How we determine that? Can anybody try to explain this? Yeah, absolutely. Okay, what is the basic thing we are having? On resistance is equals to Z into RS. Okay, now we will start with the case number 1, a depletion mode NMOS. Now will you please tell me what is Z? Z is equals to length by W, which is equals to 4 by 1. That means you know very well that Z is equals to 4. Now you can tell me that R becomes 4 into, what is RS? For it is an NMOS, absolutely it is an NMOS. What is R? 10 power 4. Now you know the unit of this is square, and here you are having ohm per square, therefore it gets cancelled, then it becomes ohm. Then this can be written as what? R is equals to 40 kilo ohm. And similarly you can talk about here for enhancement mode transistor in case number 2. Okay, you can talk about for enhancement mode NMOS transistor. Okay, now will you please tell me what is the Z value here? Okay, L by W, that is 1 by 1, which is equals to 1. Is it clear? Therefore you can tell that the on resistance for enhancement mode transistor is 1 into 10 to the power of 4. Is it clear? 1 into 10 to the power of 4. Then what is the value of this? You can write 10 kilo ohm. Is it clear? Now you can observe that here it is a 40 kilo ohm, here it is which enhancement mode transistor, that is 10 kilo ohm. Then finally you can conclude that they said to find out the on resistance between VDD to VSS. Here you can observe that when Vin is equals to 1, this transistor will turns on and this transistor will also turns on. Therefore we are having an on resistance from VDD to VSS. Here it is a 40 kilo ohm, here it is a 10 kilo ohm. Therefore you can tell that total on resistance is equals to, anybody? Absolutely. What is that? 50 kilo ohm. Is it okay? This is the problem you have to solve in your examination point of view. Is it understood? And let us discuss about the another inverter. What is that inverter? Absolutely, CMOS inverter. You can look just here. I am discussing about one more inverter, that is a CMOS inverter. Now we know very well, okay, CMOS inverter consists of two transistors. One is a PMOS transistor, another one is an NMOS transistor, where PMOS will act as a pull-up device and NMOS will act as a pull-down device. Two gates are tied together and a common input is given and an output is collected between, absolutely, an output is collected between two drain terminals of MOSFET. Is it clear, all of you? Now will you observe that we will take the ratio here. I am taking 1:1 ratio. Okay, now you can observe that here I am going to consider 2:1. Okay, now this is a question for you, and how to do this, can anybody try to tell? Okay, if you want to take the similar type of ratio, you can able to take, that is no issue. Okay, now will you please tell me how to perform this? Can anybody try to tell? Yeah, if you want whatever the ratio you are having, no issue, you can able to take and you have to perform this. Now you can, will you please tell me how to perform this one? Yeah, absolutely. First of all, what should we have to do? We have to find out the pull-up resistor and pull down resistance. Okay, now you can observe that we are going to find out the resistance for a pull-up transistor, that is R is equals to Z into RS. Now what is the value of Z? Can anybody try to tell? Z is equals to L by W. Then it becomes what? 2 by 1, that is 2. Okay, now it becomes what? Can anybody? Absolutely, R is equals to 2 into, what is RS for P transistor in 5 micrometer technology? Absolutely, what is that? 2.5 into 10 to the power of 4. Then it becomes what? R is equals to 2 into 2.5. Now what is that value? 2 into 2.5? 5 into 10 to the power of 4. Then I can say finally R is equals to what? 50 kilo ohm. Absolutely. And you can tell about the pull down transistor now. Now you can observe that R is equals to Z into RS. Now what is 1:1? Z is equals to 1. 1 into 10 to the power of 4. Why? Because there is a sheet resistance of what? N transistor. Then it becomes what? 10 to the power of 4. Therefore, what is the value of this one? R is equals to 10 kilo ohm. Now the question is, calculate the on resistance between VDD and VSS. Now you have to observe very important point from here onwards. Since it is a CMOS, okay, if you observe that when Vin is equals to 0, only P transistor will turns on, N transistor will turns off. Is it clear? When Vin is equals to 1, only N will turns on and P will turns off. Therefore, there is no path for you from VDD to VSS. Is it clear? Therefore, you can say that clearly there is no static current flow here. Therefore, you do not have any on resistance. Between VDD to VSS. Are you clear? But you have an on resistance here. If Vin is equals to 0, The on resistance for PMOS is 50 kilo ohm. Similarly, when V in is equals to 1, the on resistance for NMOS is 10 kilo ohm. Is it clear, all of you? Like this, individually you can talk the on resistance in this CMOS inverter. But if the question is tell that what is the on resistance between VDD to VSS in a CMOS inverter, the very simple thing is there is no static current flow from VDD to VSS. That means we do not have any path from VDD to VSS. Therefore, we do not have any on resistance from VDD to VSS in this case. Is it clear? That means, sorry for that. That means you can clearly tell that, okay, you can clearly tell that no on resistance in CMOS. Are you clear? And one more important point is you can tell that ratio rule doesn't applicable. Ratio rule. Okay. Ratio rule does not applicable. Is it understood, all of you? That's it, guys. This is applicable. Okay, that's it. This is the today's class. If you are having any queries, will you please ask. Thank you very much. Have a nice day.